Let's suppose that we have added the customer status attribute to the customer transaction, with the purpose of representing one of three statuses that a customer may have in the travel agency system: active, standby, or closed. To such effect, a data type called status has been defined with those three values listed. Now let's suppose that at several points throughout the application, we will need to work with active customers entered in between a pair of specific arrows. For instance, in the web panel that showed all customers and the total prices of their flights that will enable the filtering by customer name, we now want to always show active customers only, allowing users the possibility of entering a date range, so that filtering by the additions to the system within that range is also possible. Another example. We need to obtain a PDF listing to show, for each flight, and in addition to the departure and arrival airport data, the number of active customers that have been recorded with a booked seat among all customers entered until today. Or for instance, we may need to obtain a PDF listing to receive a date range, start and end, by parameter, and show the active customers entered in the system between those pair of dates. In fact, we will be repeating these three filters in all those objects. To optimize things, we may sort by customer status, because we filtered by that attribute based on equality. In order to save ourselves the time of repeating the same specifications wherever they are needed, the web panel and the previous procedures, though they could also be required in data provider groups or in panel grids in smart devices, we may include those definitions in a single place, with a name, and from there on use that name as reference. This place is the Data Selector object. We create the object under the name of active customers. And there we define the conditions. Customer status as active, customer's entry date in the system, customer added date, greater or equal to the start variable, which will be a parameter of this object to the extent that it is not empty, and lastly, customer added date, less than or equal to the end variable, also received parameter, when the end variable is not empty. We must then define the variables used as parameters. Start of the date type and end of the date type. And we also indicate the sorting by customer status for optimizing. Note that there is also a defined by node that will allow, as in the for each, the naming of attributes for them to be part of the base table determination. But which base table? Depending on the way it's used, this data selector will sometimes be just a definition that will be added to the query represented by a grid, a for each, a data provider group, or a formula. Wherever this data selector is being used, and in that case, it makes no sense to speak of its base table. And sometimes it will represent a query in itself that may be executed on the database, as if it were a for each, and returning a set for its elements to be used in something. In that case, it will make sense to speak of its own base table, which in this particular case will be customer. We'll be seeing this in the upcoming examples. Here we have saved the web panel we had under a different name, and we've defined and inserted the form, the start and end variables of the date type. If we now look at the grid's properties, we will see that we are only filtering by customer full name. So upon executing, all customers, active and the others, whose names contain what the user entered in this variable, will be shown. but what is shown will not be modified if we change these other ones. We can see this in the navigation listing. However, if we go to Properties and specify, at the grid level, the data selector we created, active customers, then the parameters property will be open to specify the parameters we should send. And upon pressing F5, the grid will only show the active customers whose names contain the user's entries in the customer full name variable, and which have been entered between the two dates specified by the user in the start and end variables. And this is already in the navigation listing. We could have implemented this by adding the data selector conditions directly in the conditions property of the grid, and the data selector order in the order property. The behavior will be the same, and what the navigation listing informs will also be the same. This means that the definition of the data selector will be combined with the grid's conditions and order properties. A data selector may be used in all grids, standard or freestyle, except in the case of transactions. This is also true for panel grids and smart devices. More info on data selectors and grids may be found on our wiki. Now let's see the implementation of the procedure that prints a web PDF with all active VIP customers entered between a pair of dates received by parameter. If we had no data selector defined, we would do this. But since we have it defined, we use it through the using clause. We want the for each to be solved using, besides its other clauses, the active customer's data selector, to which we pass, by parameter, the values of the start and end variables that this report in turn received as parameters of the object calling it. The behavior is totally analogous with the previous specification, including the determination of the base table of the for each, which will take into consideration the attributes of the for each and those defined within the data selector. When we execute the procedure directly, the start and end parameters will be empty, and therefore all VIP active customers will be listed. We can see that the navigation listing does not allow distinguishing whether we use the data selector or if we program it manually. For the case of the for each command, we could have another use of the data selector which implies executing it as an independent query to the database. We won't be seeing that in this course, but it's just a matter of using the in operator instead of the using clause. Here, the data selector's attributes do not take part in determining the base table of the for each, whose base table is, in principle, the one corresponding to flight seats. In the where, the seats filtered will be those corresponding to customers whose identifier is in the set returned by the data selector, executed as an independent query. That is to say, that the filtering will be done by the customer ID that are part of the set of active customers entered between the date pair, start, and end. More info on data selectors and for eaches may be found on our wiki. When we summarize the for each command, we saw that when we indicate that it use a data selector, we are instructing it to add its orders, conditions, and defined by to the explicit ones. So, attributes appearing as parameters will be taken into account for determining the base table of the for each, as well as those found internally in the data selector. Another possibility is to filter by the values returned by a data selector. Here we indicate that the filtering of the records of the for each be done according to whether the attribute mentioned is included in the set of values returned upon executing the data selector as a query to the database. Here, the only attribute that takes part in determining the base table of the for each is the one corresponding to the where. Any attributes appearing as parameters, or those inside the data selector, will not participate. In this case, the data selector will have its own base table, which will be accessed to obtain the resulting set of the query. And lastly, we will now see the example of the use of a data selector in a count formula. We want to print the flights, and for each of them, in addition to the departure and arrival airport data, we want to deploy the total of active passengers, customers entered, to that date, who have seats booked on the flight. To do this, we define a variable, active, which we must calculate in the source prior to printing the print block. We want to count all the flight seats using the data selector, that is, filtering by everything contained in it. More info on data selectors and for eaches may be found in our wiki. If we now need to modify the filters, for both the web panel and for the PDFs we saw, so that the customers retrieved, in addition to being the active customers that were entered between two given dates, are also VIP customers, due to the fact that the information is centralized and encapsulated in a data selector, then all we need to do is modify that data selector and add to it the condition so that all objects using it become updated automatically. In sum, the data selector is an object meant to store a set of parameters, orders, conditions, and defined by, for it to be used or invoked from different queries and calculations, and enable the same navigation to be reused several times. So where can we use a data selector? Everywhere queries to the database are specified. More info on data selectors may be found in our wiki.